This is geometry 7.4. We're going to talk about proving triangles similar using side, 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 and side, angle, side. So up here we've already talked about angle, angle. And that was one way to prove triangles congruent. Originally, when we proved about similarity, we needed to know about all three angles. The corresponding angles are congruent. And we had to know that the corresponding sides were proportional. Then we started to learn about these shortcuts. Today's shortcut is side, angle, side. So if the corresponding sides of two triangles, so these sides have to be proportional. If the corresponding sides of two triangles are proportional, then the triangles, hang on. If the corresponding sides, we're not just saying two sides, we're saying all the sides. So this one's actually talking about SSS. So the corresponding sides of your first triangle are going to match the second triangle, then the triangles are similar. Sorry about that. Now we're going to talk about side, angle, side. If the two corresponding sides of two triangles are proportional, and they're included, listen to that, the included angle, the angles will be congruent. Then the triangles are similar. So what we're looking at is if you have a small triangle here and let me see if I can do something here for you. Alright. So if we have this triangle right there, and then we come in and we make this other triangle, that didn't quite work the way I wanted it to. Of course not. It blew up with the other side of the other one. So those two triangles are actually congruent. All right, so my demonstration didn't quite work out as planned. So we'll get back to the notes. So let's take a look. What we're trying to determine here is if triangle DEF or if triangle GHJ is similar to triangle ABC. So here's ABC. Are either of those triangles similar to this one? Well, which method do you think we're going to end up using? Do we know stuff about their angles? No, so we can't use angle, angle. We don't even know one of the angles, so I can't even use side, angle, side. So I'm going to most likely talk about the corresponding sides and just the corresponding sides. So what I'm going to first look at and compare is the small sides. So the smallest side of triangle ABC is 8. The smallest side of DEF is 4. So I'm going to reduce those by the number that goes into both of those, and I get 2 over 1. Then I'm going to look at the medium side. 9 is the medium side. It's the middle number. 6 is the middle number. I can reduce that one. Looks like 3 goes into both of those. 3 goes into 9 3 times. 3 goes into 6 2 times. These are not the same. Those ratios are supposed to be the same if the triangles are similar. So I know that triangle ABC is not similar to triangle DEF. They did not create a continuous scale factor. So let's come on over and try our next two triangles. We're going to first look at the small sides. And that's going to be 8. And that's going to be 16. And that's going to reduce to 1/2. Then we'll look at the medium sides. Looks like 9. The medium side is 18. And reduce those. That is also 1/2. These are the same. That's good. We're not done, but that's good. Now we have to look at the longest side, largest side. So that's going to be 12. That's going to be 24. And it looks like they're going to reduce. And hey, all these ratios are the same. So that has a common scale factor. This triangle is twice as big, apparently, than this one. So we're able to say that triangle ABC, A to B to C, that's going up the short side, going down the medium side, is similar to triangle going up the short side and down the medium side, GHJ. And we know that by side, side, side similarity. So next, what we're doing, we're trying to show that these triangles are going to be similar. We don't have their side lengths. We don't know this side length. We don't know that side length. So we're trying to find the value of x that's going to make these side lengths all proportional. So do we have any pair of sides that we have both numbers for? The last two letters is BC. The last two letters is EF. So that's the 4 and the 10. Find the scale factor. So we're going to use 4 over 10 and reduce that. We get 2/5. I use the small triangle over the large triangle. Now pay attention to this. This is where people get confused. If our scale factor was made from the ABC triangle on top and the DEF triangle on bottom, then when I write my proportion, I have to put that smaller triangle side on top. The x plus 3, or in this case, x minus 3, is going to be on top of the fraction because it comes from the triangle that had the 4 on top. And AB is the first two letters. It corresponds with DE. So that's going to be 20. Then we can cross multiply. And then to solve this, we're going to multiply and get 40. This is where we've made mistakes before. You have to distribute into both of these. You've got to call it 5x, which many of you are really good at that, but it's also 15. 5x minus 15. Then you can do the math to move your 15 over That gives you 55 equals 5x. So when you solve this, you get x equals 11. And if you wanted to solve for this x also, we would use the same scale factor. The small triangle on top is 10. The big triangle is 2x plus 3. Because it's the variable x, I would expect it to be the same answer. So we're just kind of checking our work this time. We're distributing through correctly. And when we subtract the 6 and divide by 4, 4 goes into 44 11 times. That worked out. We got 11 for both of the x's. It should be the same. If it's the same variable, it needs to be the same result. So as long as x is 11, then we know these two triangles are going to be similar. Okay, example 3. Are the two triangles similar? Well, we'll do the same thing. We're looking at the small side, then we'll look at the medium side, then we'll look at the longest side or largest side. So the small number is 18 over the small number, which is 38. It looks like 2 goes into both of those. 2 goes into there 9 times, 2 goes into there 19 times. The medium side length is 21. The medium side length is 42. Looks like 21 goes into both of these numbers. 1 over 2. Hey, these aren't the same. These are different. If they're different, then the triangles are not similar. If the ratios reduce to different amounts, this is almost 1 over 2. If this was a 20, 9 over 20, 9 over 18. 9 over 18 would make the ratios the same. But this is 9 over 19. Not the same. So, triangle XYZ is not similar to triangle ABC. We don't have the same ratio when we compare the sides. All right, 2 more. What method are we going to use for example 4? We have 3 different methods that we can use to prove triangles similar. To prove triangles similar, use angle-angle, or side-angle-side, or side-side-side. Remember, the S's, we're looking for corresponding sides to be proportional. And the A's, we're looking for corresponding angles to be congruent. So we look here. I don't have all the angles. I don't know 2 angles of one triangle. I know I have vertical angles right here. If vertical angles, since I have vertical angles, then the angles are congruent. So those two angles are definitely congruent. I don't have any parallel sides, so I don't have any alternate interior. Nothing I know for sure. So I can't talk about that. But I might have side angle side. It looks like that's the information I might have here. So let's check our ratios. So I'm going to take the small numbers. The small number of this triangle is 9. And the small number of that triangle is 12. And when I reduce this, I get 3 over 4. All by itself, that doesn't matter. I have to compare that to the other. Let's look at the larger number. The larger number of the small triangle is 18. And the larger number of the bigger triangle is 24. Looks like 6 goes into both of these. 6 goes into this 3 times. 6 goes into that 4 times. Hey, the scale factors are the same. So now I know that triangle QRP is similar. I went down the short side to the vertical angle, then I went up the longer side. So I have to go down the short side and up the longer side. So that's going to be SRT. And we did that by side angle side similarity. Okay, last one. What do you see here? Pause the video. Try to work through this one on your own. Come on back and I'll complete it for you. Okay, we're back. Looks like we're working with triangle JKL. My suggestion to working with JKL would be to draw JKL separately. It might be difficult for you to look at the numbers if they are all crammed together. So 49, 28, and 56. Then we're going to have this triangle LKM. LKM. We have 16, 32, and 28. Well, looking at the information they gave us, it doesn't look like we know anything about the angles. These might look like 90-degree angles, but I don't know that for sure. I don't have vertical anywhere. I don't have parallel lines anywhere. I don't have any way of knowing any of the angles. This J might work if you were looking at the big triangle, but we're not looking at the big triangle. We're looking at the two smaller triangles, so that doesn't work. So it looks like we're just going to deal with 3 sides and 3 sides. We're going to try it with side, side, side. So we're going to look at the small pair of numbers. What's the smallest number we're looking at? 16. What's the smallest number of the other triangle that we're looking at? 28. Looks like 8 goes into both of those numbers. Or not 8, sorry. Maybe 4? 4 goes into both of those numbers. 4/7. Then I'm going to look at the median lengths. 28 and 49. Looks like 7 goes into both of those numbers. 7 goes into here. 4/7 again. We're getting somewhere. Now let's look at the large length. The largest number over here is 32. The largest number over here is 56. So it looks like 8 goes into both of those. 8 goes in here 4 times. 8 goes into 56 7 times. These three ratios are the same. So triangle JKL is similar to triangle LKM by side, side, side similarity. Because I showed side, side, side all reduced to the same ratio.